Welcome back to Muddy Math, where we take middle school math concepts that are a little muddy and clear them up. Today we are focusing on Activity 2 from Week 2 of the Barnstable Public Schools suggested activities for our remote learning. And it's a wonderful task from Joe Bowler's ucubed.org. It's called the Raindrop Task, and there's many ways we can think about it. The three questions I'm going to focus on today are: how do you see the shapes growing? Describe the 100th case, and make a generalization using algebraic expressions. So if you click the link in the description below, you'll get the PDF from ucube.org. It's a wonderful website to be exploring math at home in this new age of remote learning. So how do you see these cases? What I think is helpful is to draw them, even if you printed out the PDF, to draw them. So if case 1 is a symmetric series of shapes with one square on the left and the right, and then two squares stacked on top of themselves in the middle. And then case 2 repeats that, so you can see the original shape here, and then it seems like raindrops fell down onto the original shape and on the outsides of it. So we added 1, 2, 3, 4, 5 more squares, kind of like they're falling if you've ever played the game Tetris, or falling like raindrops, right? So they're falling onto the series of shapes that already exist there. And then if we want to look at case 3, that's going to continue. So we have the purple, where's my purple marker? Here it is. Okay, so we have the purple case 2, which is 3 high in the middle, 2 on each side, 1 beside the 2 stack, and then we're going to have to see the raindrops fall again. So we're going to add 1, 2, 3, 4, 5, 6, 7. So this time we added 5. On case 3, we're adding 7. Okay, so how is the shape growing, and how can we use math to think about it? So the way I would describe it growing is that for each case, 2 additional columns get added. So in case 1, we started with 3 columns. Then in case 2, we had 5 columns. And then in case 3, we have 7 columns. Okay, how many squares did I start with in case 1? In case 1, I started with 1, 2, 3, 4 squares. Then in case 2, I added 5 more, so I ended up with 9 squares. And then in case 3, I added 2 more than 5. I added 7 squares. So I have 4 plus 5 plus 2 more, which is 7, equals 11 squares. Okay, so we have 1, 2, 3, 4 in case 1, 3 columns, 4 squares. Then we have the original 4, and then we add 5 more, which is 9 squares. And then I have my original 9. See, I made a mistake. And I recognize that because it didn't seem like it was continuing correctly at the right pattern. 4, 9, 11. That didn't make sense to me, so that's okay. It's because I took the 4 from my previous numeric expression when I really should have taken the 9, right? Because there were 9 from case 2 that we built on. So it's 9 plus 7, which is 16 squares. Okay, so once I've written out the numeric expressions and kind of broke them into the final total of the squares, I see that, dun da da da. What do you think I see? What do you think I notice? Not only are raindrops in the shape of squares, right? We have raindrops that are squares. It's interesting. Just kidding. It's just a symbol. We could have circles, we could have diamonds, but squares are easy to draw. Squares are also a hint, I think. Whoever made this task might have chosen squares for a reason. Why? Because when you look at 4 squares, 9 squares, 16 squares, or raindrops, what do you notice about that series of numbers? Yes, they're perfect squares. They are perfect squares. What is a perfect square? A perfect square is, let me flip here. Oh, this is my planning board. Okay, maybe we're not going to use that. That was loud. Hope I didn't wake up the baby. Okay, so perfect squares are numbers that when you take any integer and you square it, or its opposite, because a negative times a negative is positive, but any integer or its opposite, any whole number or its opposite, since all the integers are in negative and positive, whole numbers are positive, but perfect squares are any integer that you square and the resulting value. So let's start with 0. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, right? Squaring something means we're multiplying it by itself. So 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5, which is 25, okay, and so on. So if you notice, we have 2 squared, 3 squared, and 4 squared, okay? So how can we relate that to the cases? Because the next thing is to describe the 100th case. So if we want to describe the 100th case, how should we do that? How should we do that? We want to describe the 100th case. The 100th case. The 100th case, how are we going to do that? I'm giving you time to think about it. I'm also toggling some windows on my screen, but I want to give you time to think about it. How can we describe the 100th case? Well, let's try to find a relationship between the case number and the values that we've come up with. Case 1, we end up with 4 squares, 2 squared squares, or raindrops, if we want to call them raindrops so that we don't use the word squared a whole bunch. So then in case 2, we have 5 columns, 9 squares, or 3 squared raindrops. Case 3, we have 7 columns, 16 squares, or 4 squared raindrops. Now I'm noticing a connection with the case number and the base of the power. A power is a numeric expression that has a base and an exponent. So, 3 and 2 is the same relationship as 4 is to 3, and the base here of this power is 2, and the case number is 1. What do you notice about the base of the power related to the number of squares in the image and the case number? What do you recognize between the base in the power and then the case number? The base of the perfect square is 1 more than the case. The base of the perfect square is 1 more than the case. The base of the perfect square is 1 more than the case. So how can we write that with algebra? And how does algebra help us? So let me give you time to catch up. Okay, I'm going to clear off some space on my whiteboard. But what you want to think about is how can we use algebra to generalize this pattern, thinking about the case and the base. The case is 1 less than the base. The case is 1 less than the base. So if I want to generalize that, okay, I have case 3 and 4 squared raindrops. I have case 2 and 3 squared raindrops. Case 1 and 2 squared raindrops. Okay, let me write this nice and neat for you all. And then maybe we can come up with an algebraic expression to represent this pattern. So we have 2 squared raindrops for case 1. Case 2, we have 3 squared raindrops. And for case 3, we have 4 squared raindrops. Well, how can we use an expression to correlate these cases no matter what it is? The 100th case, the 1000th case, the 0 case, the null case? Ooh, let's think if we can reverse our thinking after we do number 3. So How can I write a numeric expression to represent how to get from 2 to 1? Well, I can get from 2 to 1 by subtracting 1. 2 minus 1 gives me the case, right? Okay? Or I can say the base of the power minus 1 equals the case. Or I could look at it as the base equals the case plus 1. Okay, so let's apply that here. So I know that in case 2, so we'll call that C equals 2, the second case. We have how many raindrops? We have RD equals 9. So how can I get from 2 to 9? Well, if I add 1 to 2, I get to 3. And then I can multiply that by 3 or multiply it by itself. 2 plus 1 is 3. So 3 times 3 is 9. Okay, we're playing around with the numeric expressions, trying to see if we can substitute, find a pattern, use variables. We're going to keep going. Okay, so if we have case 3, all right, let's see if I can give you a better example here. Okay, case 3. So what if I made a little table to organize everything I've done so far? Can you see this? Yes, you can. So if the case number, and then the raindrops. So case 1, we have 2 squared raindrops, which is 4. Case 2, we have 3 squared raindrops, but I can write that as 2 plus 1 squared raindrops. Case 3, I'm going to try to expand my structures a little bit more here. Okay, I hope you can still see it. It's wiggling all around, and I can adjust the camera just slightly. There we go. All right, and I'm trying to block the reflections. Here we go. All right. So instead of using, I see this 2 here, and the 2 goes to the case, right? So I could do that here as well. The case is 1, I add 1 and square it. Okay, so here, instead of using 3, I might just say the case plus 1 squared. Does that work? Is the case plus 1 squared equal to 4 squared, which equals 16? Yes, it is. Okay, so we can say for any case, we're going to use the variable c to represent any case. I guess I can come over here, but then I don't block the reflection. So I'm going to come back over here. Okay, so for any case C, we can find the number of raindrops by adding 1 to the case and squaring it or multiplying it by itself. So let's try that. Okay, so the 100th case, what do you think that would be? What do you think 100 plus 1 squared is going to be close to? Well, I love estimating, so when I estimate, I'm thinking about 100 squared because 100 is way easier to deal with. It has zeros and ones. I love zeros and ones, okay? Catch me on Muddy Math for another day when I count in binary. How do you use your fingers in binary? I got that from Eugene Chang, but that's a digression and I'll do that another day. But let's see, so if we have case 100, whoa. So let's think about this one really quick. This was case 3. It had 1, 2, 3, 4, 5, 6, 7 columns. How many columns would case 100 have? That's another good question. But case 100, how many raindrops is it going to have, first of all? So the raindrops that it has is the case plus 1 squared. So that's going to be equal to 100 plus 1 squared, which is 101 squared, which is 101 times itself, 101. I'm just going to think to myself really quickly, what is 100 squared? Well, that's 100 times 100, and all I have to do when I'm multiplying by powers of 10 is count the zeros. So I have 1, 2, 3, 4 zeros, so it's going to be 1 and then 4 zeros. And then I count back 10,000. So it's going to be super close to 10,000. but I get my trusted handy-dandy math tool to calculate, and I get that 100 squared is 10,201 raindrops. 1,201 raindrops on the 100th case. What about the 0 case? So does it work for the 0 case? Okay, so remember our case 1 looked like this. 3 columns, 4 squares, right? Now case 0, what would case 0 look like? I think it would be just 1 square. Does this formula, this algebraic expression, generalize to case 0 as well? Let's check and find out. While I'm erasing, why don't you try on your own? So we have that the raindrops equals the case plus 1 squared. The case here is case 0, 0 plus 1 squared. In the parentheses, we simplify 0 plus 1, we get 1 squared. 1 times 1 is 1. Does it work? It does work. Okay, what about case negative 1? Case negative 1. What about case negative 1? And I'm going to move this so that I can make better space. We've answered these questions, so I'm going to kind of erase them. All right, definitely erase them, not kind of. What about case negative 1? Now, I've never even explored this yet, so we're in this together. Case negative 1. What would that look like? Well, that's tricky. Let's put it in the algebraic equation and just see what comes up. So the raindrops are supposed to equal the case number plus 1 squared. So if we have case negative 1, the one that comes before 1 raindrop, what would that look like? Can I have an image that has less than 1 squared? Let's see. So negative 1, we'll substitute c equals negative 1 in for the variable c. We get the raindrops equals negative 1 plus 1 squared. These are opposites, okay? They are additive inverses, so we get 0 squared, which is 0. Okay, so case negative 1 doesn't have any squares. This is exciting. I'm going to try case negative 2. I encourage you to try as well. All right, so case negative 2, let me change the color. What do you think is going to happen? What do you think is going to happen? How do we get the retracted images when case 0 is nothing? There's no squares in case negative 1. Right, so we went from 4 to 1 to 0. What do you think is going to happen for case negative 2? I have an idea. I wonder if you made a good guess. Make a guess. Make a hypothesis. You embrace these moments of curiosity. Okay, so case negative 2. Let's use our algebraic expression. We have the raindrops equals the case number plus 1 squared. So our case number is negative 2. We'll substitute that in for c. Okay, so we get negative 2 plus 1 squared. Do you see what's going to happen? It's very exciting. Okay, so then we get negative 2 plus 1. What is negative 2 plus 1? Let me use my quick number line. Okay, here's 0, here's negative 1, here's negative 2. If I'm adding a positive, I'm going upward and forward. So I get to negative 1. So negative 2 plus 1 is negative 1. So then I get negative 1 squared. Well, what is negative 1 squared? Remember I said it's all the integers and their opposites. So whatever, I need to just go back to my basics. I know negative 1 squared is the same as negative 1 times negative 1. Wow, we're adding integers, we're multiplying integers. What's a negative times a negative? A positive. The opposite of an opposite is positive. So we get negative 1 times negative 1 is the opposite of the opposite, which takes us back to the positive, right? So on a number line, what that looks like is, if I just think about 1 times 1. I have one group of 1. I jump to 1 once. Okay? But if I have negative 1, okay, I'm starting at 0. I jump to negative 1 times. So I jump to negative 1, but the negative times takes me to the opposite. So I like to think about negatives as opposite because 1 times 1 is 1, but negative 1 times negative 1 is telling me I need the opposite of negative 1 groups. So it takes me back to positive 1. I'll link some more specific videos to multiplying and adding integers in the cards. Should be over here when I republish this. So you can check those out if you need help with multiplying, adding, subtracting, dividing operations on integers. Okay, so then we get 1. Case negative 2 has 1 square. Oh my gosh, we're bouncing back. Let me see. With case 3, case negative 3, would that go back to case 1? What's negative 3 plus 1? Negative 3 plus 1 is negative 2. 1 closer to 0. Negative 2 squared is 4. Negative 2 times negative 2 is 4. It's bouncing back. How cool. My goodness. I don't know. I feel like a time traveler or something. What a cool task. Thank you, YouCubed, for such a cool task. I wonder how you did it. Please comment below or send me an email about how you did the raindrop task. If you look at the PDF, Joe Bullard does give you some very thorough examples of how to solve it the way she did it. But remember, math is a human subject, and you need to be doing math while you're remote with people. So whether that's the people in your home or you're contacting your friends through devices or video conferencing or texting, I don't care, but you need humans to do math. Math is a human subject. Stay connected, listen to others' perspectives, and you are going to be just fine, okay? Math isn't scary. Just give yourself a chance to try. Those struggle moments are the moments you learn. Recognize when you're frustrated and step away. Time and breath helps. Exercise helps, okay? But when you're struggling, don't run away. Struggle is good. Struggle is the moment when you learn. You hear my dog snoring? Struggle is the moment you learn. So embrace the struggle. If it's too easy, you're not learning. So find that healthy struggle. Contact me, muddymath@gmail.com, or if you're one of my students, Flynn_Samantha at our school's handle, and I will see you next time. Please let me know what other videos I can create to help you along your home learning journey. Signing off, Muddy Math, with Miss Sam, Miss Flynn, Sam, Samantha, whatever you want to call me, it's Muddy Toes. Clearing up the middle school math moments for you, embracing the struggle, and I'm stopping. Have a good day.